Hello, I'm going to be talking about Netflix Bless today, setting up just like a little Hello World example. Netflix Bless is a certificate authority, lives in AWS, it's going to sign SSH public keys for us. So let's get started straight away. Alright, we're going to go to the Bless deploy, the Netflix Bless GitHub repository. Okay, and we're just going to clone it. Git clone. Netflix Bless. Okay, I've got a load of JSON here. This is all Lambda IAM policy stuff. I'll go into that when the time comes. So we go into our Bless directory. Okay, the first thing we need to do is check that we've got Docker installed, which I do. And we're going to do a sudo make lambda deps. And that's going to take a minute or two to actually get all our dependencies for us. Okay, what we actually need to do is create a public and private SSH key pair. That private key needs to have a password associated with it. And that password, we need to encrypt it and base64 encode it. And we need to encrypt it with a key management key, a KMS key. Okay, so if I go to Amazon, there it is, key management. Okay, you see I've already blue petered one here. It's really simple to set up. Top right, just click the create key button, give it an alias, and then just next everything else, and then finish, and that sets up the key for you. The keys cost $1 a month, and I think it's 1 penny per 10,000 requests you make to it, something like that. It's really cheap. But the alias I've given mine is Bless EU West 1. You have to have a 1 key per region, basically. But I'm only using one region, EU West 1, and that's it. The only thing we need to get from these keys is this alias here and its ARN number. Yeah. So it is really simple to set up. So what we're going to do is create a public and private key pair. Bless is going to have that private key, and it's going to basically use this KMS to decrypt the password for it. Right? It also needs access to CloudWatch, and it needs access to KMS generate random as well. But that is it. They go through all that in the actual GitHub readmes. It is around here somewhere. Okay, so that's nearly done. Once that gets done, we'll basically encrypt we'll do our public and private keys. Here we go. Okay, this AWS Lambda libs has just been created for us, containing all our dependencies. What we need to do now is make a directory called lambda configs. Okay, and in here now we're going to actually generate our SSH public and private key pair. And they have the command to do that on the GitHub page, SSH key den, RSA key, 4 kilobytes. Here we go. Let's just paste that in and generate it. Now I need to enter a password. My password is just going to be 5 A's. Obviously you choose something more secure. And there it is, our public and private key. Bless is going to be using this private key basically. And we are going to put this public key on our EC2 instances. Our EC2 instances are going to be set up to trust the certificate authority. So we need to put this key on our instances. Okay, but what we need to do is encrypt our password using this KMS key. So what we need to do is create a little Python file. I'm going to call mine keyencryptor.py, and the code is in the Bless README. It's protecting the CA private key. Just copy and paste this little code in. The code that they post on there is meant to be for AWS Lambda, but I'm just going to run it locally. Okay. Forget the event in context. It's not to be used in AWS Lambda. I'm just going to basically hard code a plain text password here called A 5 times. My region here is EU West 1. Okay. Oh, and I need the key alias. Key alias is, I go to the KMS key again, bless EU West 1. There. And then if name equals name. Print lambda handler. There. Now, whatever user you're running this with needs access to KMS encrypt, as well as a couple of other things within KMS as well. But I'm just running this on an admin user right now, so it doesn't really matter. So if we just do a Python, actually what Python version do I have? Python version 2.7, I need Python 3.6 actually, Python 3.6, make sure you've got that installed. So now if I do a Python key encryptor, it's going to generate our encrypted key for us. Okay, there we go. Ignore this B thing, this apostrophe thing here. That's just Python junk. All we need is the base64 encoded key. Copy that. Actually, now we actually need our configuration. So we're going to do a bless deploy.cfg, make a new config file, and there is some example config within the README that you can download. There we go. There. Go right to the top. Our certificate, if you have a look at this certificate validity after seconds, it defaults to 120 seconds. So after 2 minutes, it'll be irrelevant. But I'm going to change it to 20 seconds just so I can demonstrate that the key, that the certificate will expire. Entropy, random seeds, and login level, just leave it as it is. The main thing here now is this bless CA section. Okay. Our KMS key, we've only got one in one region, so we don't have to worry about like multi-region keys or anything. We're just using EU West 1. And the password is a password, the base64 encoded password here. So copy that and get it in. Okay, and this here, the CA private key file, is the key file we just generated, our private key, bless CA minus. And that is all we need to do within with our Lambda. Actually, first we need to chmod 444 the private key. If we don't do that, then the Lambda is not going to work at all. It won't be able to generate any certificates because it won't be able to read your private key. So there we go. Read permissions for all. Okay, what I'm going to do now is a make publish. CD out of that directory. Yeah, I do a make publish. You see here now, a new publish directory has been created. And we got our bless lambda.zip, which we can upload to AWS Lambda. Before we do that, we need to give, our Lambda needs to have a role which allows it to use our KMS key to decrypt our password. It also needs access to KMS generate random and access to CloudWatch logs as well. So let's just set up that role and policy now. So create policy, and we're just going to have some JSON. And I'm going to use bless lambda policy.json. I'll put a link to all this stuff as well. Okay, paste. So our policy is give it access to KMS generate random and CloudWatch logs, and also give it access to KMS decrypt and describe key for our KMS key. Okay, review policy, and let's call that policy bless lambda EUS1. Okay, and now we need to create a role which has that policy attached, a role for lambda. The policy is what we just created, bless lambda EUS1. Next tags, I'm gonna not bother with tags, and the role name, again, just bless lambda EUS1, that's fine, and then create the role. Okay, now if we go into AWS Lambda, create a new function. The function name is going to be called bless, and it's going to be Python 3.6, and the role is the one we just set up, bless lambda EUS1, and create the function. Here we go. Okay, we're not going to be writing any code here because we've got a zip to upload. So let's upload that zip. And our handler is called bless lambda dot lambda handler. Okay. What else do we need? We need a timeout. 3 seconds is not long enough. I'm going to up it to 10 seconds. The first time you run it, it's going to take about 6 or 7 seconds to actually generate a certificate. So we'll just put the timeout as 10 seconds, and then we'll save. Oh, awfully slow. Right. Okay, so while that's uploading and saving, the only thing we need left to do now is set up an EC2 instance which trusts our certificate authority, and we need to set up a user who's capable of invoking the bless lambda. I've got an admin user set up, so he's already capable of doing it because he has admin permissions. Yeah, so I won't bother setting up a new user. Actually, I'll just use the admin user I currently have. So all we need to do now is go to EC2. I've already got an instance set up, but it doesn't trust the CA key yet. We've got a running instance here. Instance, let's log into that. I'm going to use the master pen key to actually log into it. -i .sh less.pen ubuntu at that. Yep. Okay. So I'm going to switch to root because I'm going to be modifying. SSHD. What we need to do is cd into etc SSH, and we need to modify this SSHD config file. So if I vi into that, and we need to set up trusted user CA keys, and we're going to point it to etc SSH cast.pub. Okay, but we haven't got an etc cast.pub now, we've got to create it. So we're going to first touch cast.pub, and I'm going to mod it 600 cast.pub. Okay, and now we need to actually log out of that quick. Our public key which we set up, this thing here, we need to put that in our cast.pub. Okay, so for SSH back in, 0 by etc SSH cast.pub. Paste that in there. And now what we need to do is restart the SSHD service. Okay, we can log out, and now we can actually generate our private keys. We actually generate our certificates and log on to our EC2 instance with it. Okay, but the first thing we need to do, I've got the lift Python bless client open up here. We're not doing anything two-factor today. We're just doing, we have KMS auth completely disabled. But there's something really useful within this. Next episode we'll go over that. There's something really useful within this, is to generate a temporary key for a bless certificate. We're just going to kind of copy and paste this. Copy and paste that. And what that's done is create a load of temporary stuff for us. It's created all those. Now what we can do is actually use the bless client. We go into the bless client directory. What we need to do is supply it with a region, lambda function name, Bastion user and Bastion user IP. These two are not really relevant for this example because I don't have KMS auth activated. This can be whatever you want it to be. But it will be relevant next episode when I go into KMS auth. The main thing is remote usernames. This is the username you want to log onto on your target machine, EC2. EC2 is Ubuntu, so I'm going to log in as Ubuntu. My Bastion IPs, I don't have a Bastion set up, but this IP is basically going to be a trusted IP, which is within the certificate. So the certificate is going to only like trust an IP from your Bastion, or in this case, from this machine that I'm actually logging in from. So my Bastion IP in this case is going to actually be my actual IP, which is this. Bastion command we don't care about. And we need this idrsa.pub, where we just did that with our temporary public keys and an output idrsa cert.pub. That's the temporary certificate that we just generated. So let's get it done. Bless client.py, region, EU West 1. Function name is called bless. Bastion user, don't care. Bastion user IP, don't care. Our remote username, that's going to be Ubuntu. And Bastion IPs is going to be curl API.ip5. Okay. Bastion command, don't care. idrsa.pub, that's going to be our .ssh bless id.pub. And our output idrsa certificate.pub is going to be ssh bless id cert.pub. KMS auth token, we don't need to supply one because we haven't got KMS auth enabled. So let's just run that now. API.ip5.org. There we go. So it took about, 5-6 seconds. And so our certificate has been wrote. has been written, but we've only got 20 seconds to actually log on to our instance with it. Right? I think we've probably already run out of time. So ssh-i .ssh bless id ubuntu at, I can't even remember the IP address. This IP, yeah. Okay, permission denied. The certificates expired already because I set it to 20 seconds. So what we're going to have to do is generate another one. So let's generate another one. Okay, and now let's log on. And there we go, we're in. And that's pretty much it. Yeah, is there anything else to say about it? Not really. If we log back out, again, I can demonstrate that it's no longer relevant. I try and SSH into it again. There, permission denied, it's expired already. So yeah, that's pretty much it. A little hello world. So if I was a user and I left a company or whatever, my I am user will be deleted, and I won't be able to invoke the blessed lander anymore. Next episode, I'm going to go into actually using a bastion with it and using KMS auth with a blessed lift client for two-factor authentication. For that, my users are going to have MFA enabled. It's pretty cool and really secure as well. So there we go. Thanks for watching.